Linear relations are represented by the equation y equals mx plus b. If you know the slope and y-intercept, you can very easily determine the equation of a line. But what if you were missing information, like the slope, or only given certain pieces of information, like a point on the line? By the end of this video, you will be able to determine the equation of a line given a variety of information, such as the slope and the y-intercept, the slope and 1 point on the line, or determining the equation from only 2 points on the line. Let's start with finding an equation of a line if you are given the slope and 1 point on the line. So in order to come up with an equation that would be in y equals mx plus b form, the first thing we're going to do is substitute the given slope in the place of m in our equation template, and the coordinates of our given point are going to go in the spots of y and x. And once we plug all of those pieces of information in, we can solve or isolate for b, the y-intercept. Once you have the values for slope and your y-intercept, you can come up with your final equation by substituting these values into the equation template. So let's give it a try. We're going to find the equation of a line that has a slope of -1 and it passes through the point -2, 3. Remember that with a coordinate point, the first value represents an x value, and the second value in the point represents a y value. To begin, we're going to start by writing out the general equation for a linear relation, which is y equals mx plus b. The question already told us what the slope of this particular line is. It happens to be -1. Now I know that in my equation template, the letter m represents slope. So in the place of m, I'm going to go ahead and input my slope value of -1, and I'm going to keep the rest of it the same. We were also given a point on this particular line, and that coordinate point is -2 and 3. Now, like I mentioned before, we know that coordinate points are representative of x and y values. So knowing this, I can take the values of -2 and 3 and also input them into my equation template in the positions of x and y. So according to my coordinate point, my y value is 3. My slope is -1, so I'm going to recopy that. And my x value is a -2. Now that has to get multiplied with my slope, so remember that you want to encase your x value in a set of brackets. And then we don't know the y-intercept, so we're just going to recopy the plus b. So now I have more than enough information to go ahead and solve this equation for b, my y-intercept. So the first thing that I'm going to do is multiply -1 by -2, which is a +2. And then I'm going to isolate for b by collecting like terms, which means that I'm going to take this +2 and bring it over to the left-hand side of my equation. That's going to leave me with 3 minus 2, and 3 minus 2 is 1. So my b value, or my y-intercept, is equal to 1. The original question did ask us to come up with an equation, so now that we know what our y-intercept value is, we can go ahead and write the final equation. So we're back again to our general equation template for a linear relation, and all we need to do is just input the slope and the y-intercept values. So my final equation is then going to be y equals -1x plus 1. Now remember, we don't have to write the 1 for our slope. We can leave that 1 out since it is attached to a variable. So you could also express the final equation as y equals -x plus 1. And now it's your turn to give it a try. We're going to find the equation of a line that has a slope of -2/3 and passes through the point 5, 2/3. So pause the video, come up with your equation, and then come back to see the full solution. So the first thing we want to do is take all of the information that was given to us in the question and input it or plug it into the correct spots or locations in our equation template. So we were told that our slope was -2/3. So in the place of the letter m, I plugged that value in. We were given a coordinate point of 5 and 2/3. So in the positions of x and y, I plugged in 5 and 2/3. So we can go ahead and start solving. So we can recopy 2/3. We have an equal sign. And then on the right-hand side, we've got some multiplication. So -2/3 multiplied by 5 is -10/3. So now it's up to you. You can choose to work with the fractions. And even if you don't really like fractions, if you have a scientific calculator, you can use it and allow it to do the math for you. Or if you want to work with simpler numbers, you can choose to get rid of the fraction. So what I'm going to choose to do is get rid of the fraction. And so what I'm going to do is look at the numbers in the denominators of my fractions. They both happen to be a 3, so I don't need a common denominator. And because my denominators are 3, that tells me that I need to multiply every term in my equation by a 3. So if we start on the left, we have 3 multiplied by 2, which is 6. 6 divided by 3 is 2. We have an equal sign. Then we have -10 multiplied by 3, which is -30. -30 divided by 3 is -10. We have a plus sign. And then 3 multiplied by b is a 3b. We can then collect like terms. So I'm going to take -10 and bring it over to the left-hand side. In doing so, that is going to become a +10. 2 plus 10 is 12. And now to isolate for b, I can simply just divide both sides of the equation by 3. 12 divided by 3 is 4, and that will give us our final answer for b. The last thing we need to do is write the final equation. So I'm just going to rewrite the equation and plug in my values for slope and y-intercept. So that's going to leave me with y equals -2/3x plus 4. Now let's take a look at some thinking or problem-solving type questions that we could come across that requires us to build the equation of a linear relation. Before we start with the example, let's recall that two lines that are parallel will have the same slope, and two lines that are perpendicular to each other will have slopes that are negative reciprocals. In the example, we are asked to find the equation of a line that is perpendicular to y equals -2x plus 4 and passes through the origin. Before we even begin our solution, let's pick out some key pieces of information that were given to us in the question that are going to be relevant to us coming up with our final answer. The first thing that stands out to me is the word perpendicular. So once I see this word, I know that I need to come up with a slope that is going to be the negative reciprocal of the slope that was already given to us. They did give us an equation of a line to work with, and in this particular equation, the slope of the line is -2. So if they're asking me to come up with the equation of a brand new line that happens to be perpendicular to the given line, I know that I need to find the negative reciprocal of -2. The second piece of information was the origin. Now, they're telling us that our brand new line needs to pass through the origin, and what I know about the origin is that it is a very specific coordinate point. It is 0, 0. So this particular point is what I'm going to be using for my x and y values. So let's start by finding the slope for our brand new line. Our slope has to be perpendicular to the slope that was already given to us in the equation. So in the equation, we are told that the slope is -2. But if we want a slope that is perpendicular, we need to find the negative reciprocal of -2. Remember that negative 2 can also be expressed as negative 2 over 1. So the first thing that we're going to do to this slope is we are going to flip it over. So if I flip it over, that's going to make it a negative 1 over 2. The second step would be to change the sign. So the slope that we started out with, negative 2, was already negative. So if I change the sign, my brand new slope is actually going to be a positive 1 over 2. So the slope that we are going to use to build our equation is going to be 1 over 2. So I've gone ahead and written out the template for our equation. We can go ahead and fill in the slope since we now know our slope is 1 over 2. And the other piece of information that we were given was that our line has to pass through the origin, which was that point of 0, 0. So knowing that, I can plug the values of 0, 0 into the letters x and y in my equation template. So my y is going to be 0. I have a slope of 1 over 2. My x value is also 0. And then I've got my plus b. So we're going to go ahead and solve for b. And it's going to be nice and simple because I know that 1 over 2 multiplied by 0 is just simply 0. And 0 plus b is the same thing as saying nothing plus b. So we can just simplify this to b is equal to 0. So the y-intercept for this particular equation is 0. Our last step is to write our final equation. All we need to do is go to our template and plug in the values for slope and the y-intercept. So my slope was 1 over 2, and my y-intercept is 0. Now, there really isn't a point to saying plus 0 because that's like saying plus nothing, so we can actually go ahead and leave that out. So our final equation for our line would be y equals 1 over 2x. This is the equation of a line that would be perpendicular to the equation that was given in the question, and it also happens to pass through the origin. Now it's your turn to give it a try. Here is a brand new problem. You were asked to find the equation of a line that is parallel to the line y equals negative 3 over 4x minus 2 and passes through the point 4, 2. Go ahead and pause the video, try to work it out, and then come back for a full solution. The first thing that sticks out to me in this question is that we are trying to come up with a brand new line that needs to be parallel to the line or the equation that was already given to us. I know that if two lines are parallel, they have to have the same slope. So the slope in this given equation is negative 3 over 4. So if I want to make a parallel line, that means the slope of my line also has to be negative 3 over 4. So I'm going to go ahead and write that out. We know the slope is negative 3 over 4. So if we want a line that is parallel, our slope also has to be negative 3 over 4. So I'm going to go ahead and write out my equation template. And I know my slope now, so in the place of m, I'm going to put in negative 3 over 4. The next thing that we can input is our coordinate point. Our line that we need to create has to pass through the point 4 and 2. So remember that we know that the first value in a coordinate point is an x value, the second value or the second number is a y value. So I'm going to go ahead and plug those in. So in the place of y, I'm going to plug in 2. I have my slope. In the place of x, I'm going to plug in 4. If I simplify this, I have 2 equals, and then I'm going to multiply negative 3 over 4 with 4. So negative 3 times 4 is negative 12. Negative 12 divided by 4 is a negative 3. I'm going to collect like terms by taking this negative 3 and bringing it over. That's going to leave me with 2 plus 3. And 2 plus 3 is 5. So my b value is equal to 5. My final step is to give a final equation. So we're going to go ahead and plug in our slope and our y-intercept value. So my final equation is going to be y equals negative 3 over 4, that was my slope, x plus 5. Here is another problem-solving or word problem type question. Chris knows that it costs $25 to take a taxi to work, which is 10 kilometers from her home. She forgets what the fixed cost is, but remembers that the variable cost is $2 per kilometer. Just in case you've forgotten, anytime you see the term fixed cost, that's just another way of referring to your y-intercept. Similarly, anytime you see the term variable cost, that is just another way of referring to your slope or your rate of change. Remember, rate of change is just the slope with units, and this is a question that has units. And for our variable cost, the units are dollars per kilometer. Question A asks us to find the fixed cost and write the equation that relates the cost in dollars of a trip to the distance in kilometers. So by asking us to find the fixed cost, they're really just asking us to solve for the y-intercept or solve for that b value in our linear relation equation. So it's very similar to what we were doing in all of our previous examples. Now, in the question, we were told the variable cost. Remember that variable cost is just another way of saying slope. So we actually already know what our slope or m value is. It is 2. The other thing that we need in order to find the fixed cost or the y-intercept is a point. Now that information wasn't explicitly given to us, so we're going to have to go back to the question and kind of pick out some of the information and figure out which value represents an x value and which value represents a y value. In order to do that, we need to take a look at the variables that are being discussed in the question and decide which one would represent an independent variable and which one would represent a dependent variable. So in the context of the question, we're talking about taking a taxi to work. The price of the taxi ride is going to depend on the number of kilometers you are driving in the car or the number of kilometers you have to travel. So my independent variable is going to be the distance, which is measured in kilometers, and my dependent variable is going to be the cost. So in the question, they tell me that if Chris needs to travel 10 kilometers, the cost for that taxi ride would be $25. So distance, the 10 kilometers, is independent. That's going to be plotted or represent the x-axis or the x value. So 10 is going to be the first value in my coordinate point. And then the cost is $25, and cost is on the dependent axis, or it represents a dependent variable, and so that automatically correlates to a y value. So the point that I can use in my equation template is going to be 10, 25. So we identified our slope, we have our point, and now we need to write an equation. They want us to write an equation that relates the cost to the distance. So while we do have our regular equation template, we might also want to pick different letters to represent the different variables that we're talking about in the question. So the things that are going to stay the same are the m and the b, or the slope and the y-intercept, but we can switch out the letters x and y. So I know that on my y-axis, or my dependent axis, it is represented by cost. So perhaps instead of y, maybe we'll use a capital C to represent the cost. I know my slope is 2, so I'm going to go ahead and input that. And then instead of the letter x, we need to pick a variable that represents distance, since distance is represented on our x-axis. So perhaps we can use the letter d. And then we have plus b. We have to keep b as it is because b is the standard letter used in mathematics to represent our y-intercept. So this is the equation template that we are now going to work with for the rest of this question. We need to use our equation to find the fixed cost. So what I'm going to do next is take the point that we were given in the question and plug it into the equation in the correct spots. So the value 10 represents a distance. Remember, it was a 10-kilometer distance. So that 10 can go in the place of the letter D. And 25 was a $25 cost, so 25 is going to get plugged into the place of C. So that's going to make my equation look like 25 equals 2 multiplied by 10 plus B. So I'm going to go ahead and solve. 2 multiplied by 10 is 20. I'm going to bring 20 over to the left-hand side, which is going to turn it into a minus 20 when I collect like terms. And 25 minus 20 is 5. So my B value, or my fixed cost, is 5. So what that represents for this situation or question is that even if you don't go anywhere with the taxi, there is still a fixed cost of $5. So just to book the taxi and kind of get the taxi driver to take you anywhere, it's a flat rate of $5. So now that we know the fixed cost, I put it all together in one final equation. So that is C equals 2D plus 5. So what this means is the cost for the taxi, it is $2 for every kilometer that you drive, plus a fixed cost of $5. Question B asks us to find the cost of a 14-kilometer trip. So now that we have our equation, we can simply take 14 and plug it into the place of D. That's our distance. So 2 multiplied by 14 is 28, and 28 plus 5 is 33. And then we can go ahead and write a concluding statement. We can say, therefore, the cost of the trip would be $33. In all of the previous questions and examples that we solved, we were given the slope. So we always had a value that we could substitute in the place of m in our equation template. But what if you weren't given any information at all about the slope? And instead, all you were given were 2 points on the line that you were trying to develop an equation for. So in this second part of the video, we're going to look at how to find an equation if you were only given 2 points on the line. So the general steps are as follows. Your first step would be to calculate the slope. So since it wasn't given to you, you need to calculate it yourself. If you are given 2 points, well, then the easiest way to find the slope would be to use your slope formula or your slope equation. y2 minus y1 divided by x2 minus x1. Once you find the slope, you're going to substitute your slope in the place of m in your equation template, and then you can choose any of the 2 points to plug into the letters x and y, just like we did with our previous examples. A coordinate point can always be put into the place of x and y, and once you do that, you then have enough information to solve for b. Once you have the values for m and b, you can go ahead and write your final equation. So let's try it out with this example. We need to find the equation of the line that passes through the points 1, 3, and 3, 9. So the first thing you want to do with your 2 given points is label them. So I'm going to label the point 1, 3 as x1, y1, and the point 3, 9 I'm going to label as x2, y2. These are the numbers that I'm then going to plug into my slope equation. y2 minus y1 divided by x2 minus x1. So my y2 value is 9 minus my y1 value, which is 3, all divided by my x2 value, which is 3, minus my x1 value, which is 1. 9 minus 3 is 6, and then denominator we have 3 minus 1, which is 2. 6 divided by 2 is 3. So my slope is 3. So I'm going to go ahead and write out my basic equation template, y equals mx plus b. And I'm going to go ahead and plug in my slope that we just calculated, which was 3. My next step is to plug in numbers in the place of x and y. Now, I've got a nice variety that I can choose from because I have 2 points that were given to me in the question. So really, it's your choice. You could choose the first data point, 1 and 3, or if you like the second one better, you could choose the second data point of 3 and 9. Doesn't matter which one you choose, you should still come up with the same answer for B once you do all of your solving. So I'm just going to pick the first point. So my y value in the first point is 3, so that's going to go in the place of y. My slope is 3, and the x value in the first coordinate point was 1, so I'm going to plug that into the place of x. And I'm going to go ahead and solve for b. So 3 multiplied by 1 is 3. If I bring 3 over to the left-hand side, that's going to become 3 minus 3. And 3 minus 3 is 0. So my b value is 0. Our final step, as usual, is to write our final equation now that we have values for both the slope and the y-intercept. So into my equation template, I'm going to plug in my m value, which was 3, and I'm going to plug in my b value, which was 0. And as we mentioned before in our previous example, there is no point of saying plus 0, since that's like saying plus nothing. So you can actually leave off that plus 0. So the final equation would be y equals 3x. Now it's your turn to give it a try. You need to find the equation of the line that passes through the points 3, -4, and 2, 5. Go ahead, pause the video, give it a try, and come back when you're ready to see the full solution and the final answer. So the first thing that we need to calculate is the slope. So I labeled out my points x1, y1, x2, y2, and I went ahead and substituted them into the slope formula. Be careful again when you are working with negative numbers. You always want to enclose or encase your negative number in a set of brackets. So if I go ahead and calculate this, my slope is going to work out to be 5 minus -4 in the numerator. 5 minus -4 is a positive 9. And in the denominator, we have 2 minus 3, which is -1. So for the slope, 9 divided by -1 is -9. The next thing I want to do is take my value for my slope and one of the points and plug all of those values into the general template for a linear relation. So I'm going to choose to work with the second coordinate point this time, just to change it up a little bit. So in this second coordinate point, the y value is a 5. My slope, which we just calculated, is -9. And the x value in the coordinate point that I chose is a 2. So I'm going to plug that in. And then we've got plus b. So -9 multiplied by 2 is -18. I'm going to go ahead and collect like terms. So I'm going to take -18 and bring that over. That's going to become 5 plus 18. And 5 plus 18 is 23. The final step is to take my answers for m and b and plug them back into the equation template. So my final equation is going to be y equals -9x plus 23. All right, it's time for our final example, our final problem, and I've saved the most challenging one for last. We need to find the equation of the line that has the same x-intercept as the line 2x plus 3y minus 4 equals 0, and the same y-intercept as the line 8x plus 5y minus 20 equals 0. There is a lot of information given to us in this question, so my suggestion is to take it one piece at a time. The first thing that we need to determine or figure out is the x-intercept for the line or the equation 2x plus 3y minus 4 equals 0. So in a previous video or lesson that I made, I showed you how to find x and y intercepts. If you need a refresher, you're more than welcome to go back and take a look at that video. I'll link it in the description box below. But for time being, remember that if you are looking for an x-intercept, you are going to set y equal to 0. So that means in your equation, wherever you see the letter y, you're going to put in a 0. So I went ahead and recopied my equation, except for in the place of the letter y, I replaced it with a 0. So we're going to go ahead and do the math. So 2x, 3 times 0 is 0, so that's gone. We still have a minus 4, and we're still equal to 0. So we want to go ahead and collect like terms. So that means I'm going to take this minus 4 and bring it over to the right-hand side. And that's going to leave me with 2x equals 0 plus 4. And 0 plus 4 is simply 4. So to isolate for x, we are going to go ahead and divide both sides by 2. And so I know that x is equal to 2. 4 divided by 2 is 2. Now, because they asked us for an x-intercept, remember that you want to express your answer as a coordinate point. So if I had to write this as a coordinate point, I'm going to make a bracket. Remember that your y value was set equal to 0. So in the place of my y value in my coordinate point, I'm going to put a 0. And our x value for our coordinate point is the x value that we just determined, and that was a 2. So my x-intercept is located at 2 and 0. Going back to the question, the second thing that we needed to determine was a y-intercept, and the y-intercept had to be the same as the y-intercept from the line 8x plus 5y minus 20 equals 0. Now, there are two ways that you could come up with a y-intercept. We could try to follow the same method that we just did, except for when you are solving for a y-intercept, you are going to set x equal to 0. The other thing that you could also do is just take the equation that you were given, and notice, first of all, that it is not in proper format. It is not in the form y equals mx plus b. You could simply just take that equation, rearrange it, put it into y equals mx plus b format, and then once you get it in the right format, remember that the number that's in the position of your b value, well, the b value is your y-intercept. So you could just pick out the value that way. So two different ways to solve it. Both methods are going to give you the exact same answer. One is a little bit quicker than the other, but again, it comes down to your personal preference on how you want to solve it. So let's go ahead and use the exact same method. So to find the y-intercept, we're going to set x equal to 0. So I went ahead and recopied the equation, except for in the place of the letter x, I've put in a 0. So I know that 8 multiplied by 0 is just 0, so that's going to leave me with 5y minus 20 equals 0. So I need to separate my terms. So I'm going to bring this negative 20 over to the right-hand side. That's going to leave me with 5y equals 0 plus 20. And 0 plus 20 is simply 20. To isolate for y, I'm going to divide both sides by 5. And that's going to give me a y value of 4. So my y-intercept is 4. Remember that we need to write this or express this as a coordinate point. So to do this, I'm going to write my coordinate point as 0 and 4. Remember, our x value is 0 because we set x equal to 0, and our y-intercept, or our y value, was the value that we solved, which was 4. So we found those two key components. We needed an equation that would have the same x-intercept as the line that was given in the question, and it also had to have the same y-intercept as the line or the equation that was given in the question. So we found those two numbers, but now we still have to go ahead and build our brand new equation. In order to do that, we need to be able to fill out the key information or the key components of our template y equals mx plus b. Those two key components are the slope and the y-intercept. So let's write this down. We've got y equals mx plus b. Okay, we don't have our slope, so we don't know what to put in the place of m, but we do have our y-intercept. So we do have the number that we can replace for the letter b. Our y-intercept was 4. So we know that we can have a 4 in the place of the letter b. So really, the only thing that we're missing now is m. And remember that you can find the slope if you have 2 points, and you can plug those 2 points into the slope formula. So remember, our 2 points are the x-intercept and the y-intercept that we just calculated. Our x-intercept was the point 2 and 0, and our y-intercept was the point 0 and 4. I can go ahead and label these as x1, y1, x2, y2. So I'm going to take those numbers now and plug them into my slope formula. My y2 value is 4 minus my y1 value, which is 0, divided by my x2 value, which is 0, minus the x1, which is 2. So 4 minus 0 is 4. 0 minus 2 is negative 2. And 4 divided by negative 2 is negative 2. So our slope value is going to be negative 2. All right, now we're finally ready to put together our final equation. So we've got y equals our slope, which is negative 2x, plus b. Our b value was our y-intercept, which was 4. So our final equation is y equals negative 2x plus 4.